Hello everyone, welcome to the presentation. I am MD Nazmul Haq, presenting the paper titled Towards an Attention-Based Accurate Intrusion Detection Approach. On behalf of my team, consists of Ornabode from Bangladesh University of Business and Technology, Bangladesh, MD Shohrab Hossain from Bangladesh University of Engineering and Technology, Bangladesh, and Suryadipto Mojumdar and myself from Concordia University, Canada. At first, I would like to thank the anonymous reviewer for their comments and advice. This work was partially supported by the Natural Science and Engineering Research Council of Canada under Discovery Grant N02815. So, first of all, what is intrusion detection system? So, in a intrusion detection system, it mainly identify intruders. So, in our works, we will consider the external intruders, and we mainly work with network-based intrusion detection system, and we used anomaly-based intrusion detection techniques. So as with the growth of internet, the percentage of internet users increases, as well as the number of connected devices and connections per capita also increases, which produce a lot of network traffics. And with the increasing volume of network traffic, there is an alarming rise in different types of attacks. From global 2021 forensic highlights from Cisco, it shows that by 2023 the DDoS attack will be doubled from 2018. So it is the high time to work with network intrusion detection system. There are a lot of existing works in the literature, but most of the existing works focused on the accuracy, but they still strive to achieve a good recall score or minimize the false negative rate, as well as minimizing the false positive rate. Most of the existing works mainly based on the earlier dataset, for example, DARPA dataset from 1999, KDD dataset from 1999, NSL KDD dataset, CSIC 2010 dataset, etc. And uh, additionally, most of the recent models, especially attention-based network intrusion detection models, are comprised of several layers, which renders computational overhead. We are going to build a network intrusion detection system that will remove these gaps and provide a better result. So this is the overview of our systems. So in our systems, we first pre-process the input. For pre-processing input, we use tokenization and build our vocabulary. Then we use padding and truncation in the sequence. Then we use the embedding. Then we finally combined different version of deep learning models, like we combined CNN, we combined LSTM. LSTM helps to correlate among sequences. We then used attention mechanism, which helps to focus on important parts. Then we use GRU model, which capture missing information, or that the information that might be missed by the attention mechanism. So here is the parameter view for our models. CNN layers have one layer with 256 filters. LSTM has one layer with 20 nodes, and GRU has one layer with 20 nodes. Now I will explain the experimental setup. In our experimental setup, first I will describe the datasets. We use 4 different datasets. The first one is the most recent one, which is CSE CIC IDS 2018 dataset. Then we use NSL KDD dataset, and we also use original KDD 1919 CUP and CSIC 2010 dataset. So in all this dataset, we actually worked with different types of attacks. We worked with DOS attack, probe attack, R2L attacks, U2R attacks, and this table shows the statistics of KTG19 and NSL KTG dataset. This table shows different kind of attacks that has been captured in CSE CIC IDS 2018 dataset. CSE CIC IDS 2018 dataset actually captures brute force attack, DOS attack, web attack, infiltration attack, botnet attack, and DDoS plus port scan attacks. Here is the experimental setup for our experiment. We used a Intel Xeon based CPU with 2.3 GHz processor and 12 GB of physical memory. We used Pythons with TensorFlow based keras. We used NRM optimizer to adjust weights, and the categorical cross entropy is the cost function during the training. We also used one-hot encoding technique to convert labels into numerical forms, and k-fold cross-validation has been used in the testing steps. We used F1 score, recall, and F1 score and recall score for evaluating our model performance. So F1 score is the harmonic mean of precision and recall, which is described in the equation. So here is the result from CSC CIC IDS 2018 dataset. We actually compared our proposed model with existing different techniques. We deployed CNN, a combination of CNN and LSTM, and our proposed model, which is comprised of CNN, LSTM, attention-based mechanism, and GRU model. So from this result, it is prominent then for most of the data sets from CSE CIC IDS 2000 dataset, our model performs better than CNN and CNN LSTM, and we get nearly optimal result for our proposed model, and we get average 95.41% F1 score for our proposed model. We get a comparatively poor result for the dataset extracted from 22 February and 23rd February 2018, because for those date for this dataset, the anomaly data is less than 0.01%, and we actually used a balanced dataset for these two dates. For NSL-KDD data, we tested with different values of k-fold cross validation. The table actually depicts the result for different cross validation setup. We find best result using 10-fold cross validation result, where F1 score is 99.22%, and we also get a good result for 8-fold cross validation. But overall, 10-fold cross validation provides a better result than others. We also experiment with KDD 1919 and CSIC 2010 dataset. KDD 19 dataset outperforms all the existing works in terms of F1 score and recall score, but we get a relatively lower score in CSIC 2000 dataset because CSIC 2010 dataset was primarily built for unsupervised learning, while our approach is mainly a supervised learning. This is the comparison graph between our model and CNN and CNN LSTM models using CSE CIC IDS 2018 datasets. So it actually the figurative representation from the previous table. From this is actually F1 score from different datasets. It shows that our proposed model performs better than existing models. This is the recall value from the CSE CIC IDS 2018 datasets. It shows that our proposed model outperforms the nearest variants, which are CNN and CNN LSTM. And it is also noticeable that CNN actually performs better than the combination of CNN and LSTM. We also compare our proposed model with the highest score existing literature model, which is LUNET. So using NSLKD dataset as LUNET model used NSLKD dataset instead of the most recent dataset. From the result, it is prominent that our proposed model is uh, for F1 score, our proposed model closely follows LUNET and achieving almost similar or even better score for tenfold cross-validation. It is also worthy to mention that our proposed model is a lightweight model with fewer layers compared to LUNET. Regarding recall score, our model outperforms LUNET, and except for the twofold correlation, where our model has relatively lower score. So here is the main conclusion of this presentation. We investigate the potential of combining the state-of-the-art neural network models. We combined CNN, LSTM, and GRU with attention mechanism, where attention helps the model to selectively concentrate on more relevant factors for improving the accuracy of intrusion detection system. We utilize state-of-the-art benchmark network traffic datasets, including NSLKDD dataset and CSE CIC IDS 2018 dataset. We experimentally shows that our proposed model can improve the accuracy, i.e. F1 score and recall score, in comparison to other existing neural network models. So on average, the F1 score of our model is 95.41%, where the F1 score of CNN based models is 81.87%, and F1 score of CNN LSTM based model is 83.5%. And our model also performs better than LUNET, which provides the best result from the literature. So our works also has some limitation, like we have considered anomaly detection as a binary classification problem, but it can be generalized and multi-class classification can be used. Our works can also be extended with different hyperparameter values of CNN, like with different setup of activation function, loss function, and learning rates. The impact of adding more layers to CNN and LSTM or using bidirectional LSTM would also be investigated in the future, as we only used one CNN layer and one LSTM layer. Currently, our intrusion detection system is offline, but it could be made online as an application to deal with online data. Thank you all. Here is the reference of the works that has been mentioned in the presentation.